Asteroids are believed to be rocky leftovers from the formation of the Sun and planets. Dubbed small planets, these ancient rocks are formed of a wide variety of minerals and materials. From their components, astronomers and scientists have gathered that many of these asteroids crashed billions of years ago, ultimately becoming planets. Contrary to our belief, asteroids are not always a potential destruction material. Instead, they might potentially aid in Earth's rescue. Meteors are bits of asteroids, or very tiny asteroids. These asteroids are rich in a variety of materials and other substances, many of which may also be found on Earth. About 5,000 years ago, ancient civilizations began mining meteors for metals like iron and nickel in the Bronze Age. As a result, widespread use of iron would usher in the eponymous Iron Age. Astronomers also claim that asteroids are a good water supply and rare metals like platinum. This goes to say that these substances are open for mining to bring them back to Earth, or in the case of water, to a moon base or space station that orbits the Earth. People are now curious and interested in this venture, eagerly awaiting the mission's approval. Interestingly, 6 enterprises with eyes set on neighboring rocks have been backed by investors in the past decade. The effects of these missions on Earth's ecosystem may be far more significant. With all set on the mark, no one thought of conducting a thorough analysis of its effect on Earth's ecosystem. A carefully conducted research by Andreas Hein and others at France's University of Paris-Saclay has changed the narrative. These researchers have tallied the CO2 produced by asteroid mining operations and compared the results to those produced by the same operations on Earth. The implications of their findings for the potential gains from asteroid mining are startling. They've discovered that greenhouse gases are released into the environment in large proportions during rocket launches. The rocket's first stage fuel burns to produce carbon dioxide in the Earth's atmosphere. The second and third phases are unnecessary since they occur outside Earth's atmosphere. When rockets burn fuel, 3 kilos of carbon dioxide are released for every kilogram of fuel. In addition, nitrous oxide, a greenhouse gas around 300 times more potent than carbon dioxide, is produced when a large portion of a re-entering vehicle ablates in the high atmosphere. An estimated 20% of the shuttle's mass is lost as N2O with each landing. From this analysis, Andreas Hein and company concluded that extracting 1 kilogram of platinum from an asteroid would cause the emission of around 150 kilograms of CO2 into Earth's atmosphere. Large-scale asteroid mining operations, however, have the potential to reduce this to about 60 kilograms of CO2 per kilogram of platinum. According to the mining industry, approximately 40,000 kilos of carbon dioxide are produced during the extraction of 1 kilogram of platinum on Earth. Compared to space mining, the global warming impact of Earth-based mining is many orders of magnitude bigger, as stated by Hein and company. The water data is also quite promising. These authors determined the amount of carbon dioxide released during an asteroid mining operation that delivers water to locations inside the Moon's orbit, a so-called cislunar location. They evaluate these results in relation to the emissions produced by launching the same quantity of water from Earth into space. The main distinction is that Earth-based water-carrying vehicles can only transport a tiny fraction of its mass as water. An asteroid mining spacecraft can transfer its mass and water several times to cislunar orbit. According to Hein and company, substantial reductions in greenhouse gas emissions may be accomplished. The data involved are absolutely massive. Eventually, it will be necessary to consider more elements. Rather than relying on coal for electricity production, the mining sector on Earth may benefit from using renewable energy sources. Eco-friendlier fuels might potentially make rocket launch operations more sustainable. Both of these factors would affect the results. Mining elements uncommon on Earth have a tendency to make their miner wealthier. Though it may be costly, asteroid mining expeditions may be worthwhile. In particular, asteroids contain resources that astronauts may put to good use. The same water may be used to make oxygen for astronauts to breathe or hydrogen for spaceship fuel. Helium-3, a specific isotope of helium, could be extractable by mining. A tiny coating of this lightweight material from the Sun is on the surface of every atmosphereless planet, including asteroids. It may be able to convert this into energy by nuclear fission. That is to say, from a monetary perspective, these expeditions could not cost very much at all. Ceres is the most prominent asteroid in the asteroid belt, with a diameter of roughly 980 kilometers. It is so enormous that, according to some scientists, it could technically be regarded as a planet. Because of its properties, Ceres has become an excellent target, a much more challenging one to say the least, due to its abundance of ice water. For the purposes of these mining expeditions, this may be the perfect hub. Asteroids that might be ideal targets for such expeditions are of considerable interest, with many people emphasizing massive nearby asteroids. Asteroids and the potential profit from such expeditions are calculated on one website, Asterank's Asteroid Value Database. There are now many asteroids with values of more than $100 trillion according to Asterank. However, Ryugu is the most lucrative, with an estimated value of $82.76 billion and a profit of $30.8 billion. Lucy, NASA's newest probe, was launched in October on a historic mission to examine Trojan asteroids in Jupiter's neighborhood. The asteroid 16 Psyche is 227 kilometers in diameter, which is longer than the most significant length in Cyprus. It is rich in iron and nickel and was previously estimated to be valued at approximately $10 quintillion, which is more valuable than the whole world economy. However, the actual value is still up for discussion. The environmental effects of mining are becoming more prominent, and this excellent effort should assist in concentrating attention on these issues. Not included in this study are other types of emissions. The emissions from ground control on Earth or the building of launch pads are not included. Another factor to consider is the continual damage that rocket launches do to the ozone layer. Therefore, more tremendous effort is required. However, as the asteroid mining business develops, the need for accurate environmental life cycle evaluations will grow. Hein and colleagues have made a critical first step in this direction. Another primary motivation for these expeditions is scientific exploration. After all, asteroids may contain the key to deciphering the mysteries of how our solar system and planet came to be. This does not imply that interest in asteroid mining has not been sparked in other areas. But today, we can mine for iron and nickel on Earth. The big question is, why would we risk lengthy, challenging, and costly trips to space for something that could be mined here on Earth? Again, this is due to several factors. To best explain this, let's say mining on Earth, particularly today, is very harmful to the environment. The extraction of iron, amongst others, releases acidic substances like sulfuric acid and produces several other hazardous byproducts. Alterations to the landscape are a common byproduct of iron mining, which may devastate wildlife habitats and have far-reaching environmental effects. These widespread effects exacerbate a catastrophic climate crisis since iron mining occurs everywhere. If asteroids were mined in space instead of the Earth, we wouldn't have to worry about these repercussions as the Earth will be safe. Do you agree with this? Let us know your thoughts in the comments section below. Stay tuned to our channel for more updates of space news coming your way soon. Thanks for watching.